Hey everyone, I wanted to post this video because I got a question today in class that deserved a better answer than the one I was able to give. Because I thought it'd be a lot longer, or it would take longer than I wanted to spend going over it. But that's why I'm making this to hopefully explain it to those of you who are interested in something a little more comprehensive. So the example this came up during was basically from we were trying to find an indefinite integral for tangent cubed of x. So I've revised that example a little bit. Instead of just looking at the indefinite integral, what I want to do instead is I want to find a function and I want to give myself enough information to find that arbitrary constant c. So I'm saying that we know that basically whatever function we have passes to the origin. When x equals 0, y equals 0. So knowing that, for all these indefinite integrals, we have just been leaving c unresolved, but now we're going to be able to find out what that value is. So we're going to have a choice later on, but right now, what we kind of have is in common is that no matter how we want to integrate tangent cubed of x, we're going to have to take a tangent squared and rewrite that as secant squared of x minus 1. That's going to give us these two integrals that, the same ones we had in class. So integral of secant squared x tangent x dx minus the integral of tangent x dx. So we know that from substitution, we can rewrite tangent of x as sine of x over cosine of x, and that gives us this natural log of cosine of x plus c. Natural log of absolute value of cosine of x plus c. So really the question is, how do we deal with the integral of secant squared of x tangent of x? So one thing we talked about in class, specifically with tangents and secants, is that it's all about the parity of those trig functions. So basically the question we have to answer is, do we want to have u equal to tangent of x, or do we want to have u equal to secant of x? And one of the conclusions that we landed on today is that it all comes down to what you can leave yourself to assign to this du. So if you have u being tangent of x, then that means du is secant squared of x dx, which is only going to be possible to get if you start with an even power of secant. So for the function we're trying to integrate, we have our power on secant is 0. That's an even power of secant. So we could go u equals tangent x. But in the other case, if we want u to be secant of x, that means that we need to have our du is going to be secant x tangent of x dx. So basically, we need a way to get to, we need the power on tangent to be odd. So we meet both those conditions. So we have a choice here. So if we do both those integrals in both of those ways, then no matter what, we get the integral of u du, which is always going to give you 1/2 u squared. But the difference comes from what is that u? In one case, I get 1/2 tangent squared of x. In the other case, I get 1/2 secant squared of x. So very clearly, it looks like we did an integral in two different totally legal ways and got two different results, which we know is impossible. If a function has an integral, it has a unique integral, especially when I have enough information to figure out what c is. So let me show you why, even though those look different, we're going to wind up in the same place. So remember, we're trying to figure out what this function is, including a specific value of c. So let's do this for both those functions. So for this method here, we have 1/2 tangent squared x plus natural log of absolute value of cosine x plus c. And I know that when I plug in is 0 for x, I should get 0 for the overall function. So plugging in 0 for all my x's, that gives me the piece of information that c equals 0. So when I go that route, my function is f of x equals 1/2 tangent squared x plus natural log of the absolute value of cosine x, no constant. On the other hand, if we go with the secant squared of x, what happens when I plug in 0 for all those x's? Well, in that case, I get that c is equal to negative 1/2. So again, looks like I'm just making these functions more different. So in this case, I get the function f of x equals 1/2 secant squared x plus natural log of absolute value of cosine x minus 1/2. So now let's look at my two functions that I have side by side. Clearly they look different, but let's show that they really aren't. So I'm going to rebuild the Pythagorean identity for secants and tangents. So I have 1 plus tangent squared x equals secant squared x. Now what I'm going to do with that is I am going to take the first box right there, the one with secant squared in it, and I'm going to replace secant squared with 1 plus tangent squared x. When I do that and distribute the 1/2, you see that the 1/2 here and the negative 1/2 here cancel. So after doing that substitution, I get 1/2 tangent squared x plus natural log of absolute value of cosine x, which is now, I didn't change this function, I just re-expressed it into something that looks different but is equivalent. And now these, basically I've shown that I've gotten the same integral, I've gotten the same function using those two different branching paths. So hopefully now you can see why I didn't answer this question in the detail it deserved in class, but I did want to put together the explanation that I would have liked to have given you. So I hope this makes sense. If not, please let me know what your questions are and I'll get back to you.